And if you are not able to satisfy all code coverage criteria, basically what you have to do, you have to go back to your requirements and to have derive additional test cases. If you have no requirement, you have to first generate a requirement and then derive your test. And if you have finally satisfied all your code coverage criteria, you have basically shown that your application works as intended and it works in compliance with your requirements, which proves a certain level of quality of your software. Next, I want to introduce some widely used code coverage metrics. First, we have statement coverage, meaning that each statement in the code has been executed at least once. We have here on the left side a short code example with 2 if blocks, and on the right side we have 2 execution paths through our code. And if we combine these 2 execution paths, we've executed both branches of our first if block and the true case of our second if block, and so we have satisfied the requirements for statement coverage. The next one is branch coverage, requiring that each branch has taken all possible outcomes at least once. We have the same example with our 2 execution paths, and for both if blocks, we have covered all branches, the 2 branch and the 4th branch. The third one is decision coverage, which means that each decision in our code has taken all possible outcomes, and this is quite similar to branch coverage. There's only the difference is only a matter of the definition of the terms decision and branch. Here we have decisions. Decisions consist of conditions and Boolean operators. Here we have the first and here we have the second decision, and this is a condition and a decision at the same time. And branches are basically alternative set of program statements. This means this decision has 2 branches and this decisions have no branches. And that's where the difference between the 2 comes from. The basic problems with all these metrics is that they are designed for the evaluation at source code level. However, TRACE32 uses an approach that starts with the object code level of the software. And the basic problem we cannot apply the source code level metrics directly to the object code. That's not possible in all cases. And the second problem is that you cannot transfer results between the 2 levels without additional verification. That's why it is suitable to introduce a second set of code coverage metrics which are specific for the object code level. We have object code instruction coverage, which is quite similar to the statement coverage. Each machine code instruction has been executed at least once. Then we have object branch coverage, requiring that in addition that each conditional branch has been both taken and not taken at least once. And the third one is decision coverage, requiring that each conditional instruction has been evaluated both true and false. These are the 3 object code metrics we are going to use. And to show or to prove code coverage at the object code level, basically we use the trace information, and we use the object code information which resides in the memory of the target, and we then have something like this. We have the memory addresses, we have the machine code instructions, and we have for each machine code instruction we have a flag for the execution status derived from our trace data. This OK means it has been fully covered, and only executed means that the corresponding, we have here these 2 flags not executed and only executed because we are dealing with an ETMV1, and we have access to the execution status of all conditional instructions, and only executed means the conditional requirement has been evaluated only true, and not executed means the opposite. For PTM, it looks similar, but this time we use a different code coverage flags for the execution status of conditional jumps, because for the PTM we are not able to derive the execution status of all conditional instructions, including those which are not conditional jumps at the same time. So basically here we use not taken and taken, and all the other instructions can only be never or okay, meaning fully covered or never executed. Now I want to link these findings to the metrics I've presented earlier. For ETM, we can show object instruction coverage and object decision coverage. For the PTM, we are able to show object instruction coverage and object branch coverage. This screenshot shows a summary of the code coverage results on the object code level. You have here memory regions, and this is the coverage result. And on the right side, we have some symbolic information which is connected to this memory locations or ranges. So basically, now we are able to determine at object code level which of these code coverage metrics can be satisfied. But what we want in addition, that we are able to verify if we have also satisfied any of the source code level metrics. What we require here is a transfer of the results from the object code level to the source code level. And what we want to have, we want to derive statement coverage from the results of object instruction coverage. We want to be able to derive branch coverage from object branch coverage and object decision coverage, and we want to show decision coverage by using the results of object decision coverage. And the link between the two levels is the compiler, because the compiler takes the source code and generates the object code. And the information that is provided by the compiler is the symbolic debug information. And what we know, if we use the debug information, we know which instructions at object code level are linked to which instructions at source code level. And what we do to transfer the code coverage information, we just map the information from the object code to the source code. This will become more clearer with this slide. If we look at this example, we have an if block at source code level, and this is translated to a compare instruction and a conditional jump at object code level. And we see from the code coverage information that this is not fully covered. And what we do, we just map this information to the source code, and now we can say that this if block does not meet the requirements of decision or branch coverage, because it has not been fully covered yet. To sum this up, if we have the trace information of an ETM, we can show statement and decision coverage at source code level, and if we have trace information of a PTM, we can show statement coverage and branch coverage. TRACE32 is not only able to provide code coverage information for certain statements, but it can also give a summary of the code coverage information gathered so far. We have several display modes. We can show the information for modules, functions, lines, or static variables. Then you end up with something like this. This is the display for the function level. You have a tree structure with all the elements. You have the module, you have the functions of the module, and you have the high-level language lines. And for each item, you have the result of the code coverage analysis here, the code coverage tag, and right of it the code coverage value that was, or percentage that was determined. What is also possible, you can generate your own code coverage display. What you have to do, you have to create a group which can consist of some program sections, some ranges, functions. As you see here, we have 3 functions, and then you can display in a window the code coverage information only for this memory range. All other ranges are suppressed, and this implements a basic filter of the code coverage information. Another important point for code coverage is the import of results. Of course, you should be able to split a larger test into several smaller ones, which are executed independently from each other. And afterwards, you should be able to generate the full code coverage information for the complete set of tests. You can do 2 approaches, which are available here. First one, you perform your tests and save the trace information, and afterwards you load back the trace, the saved trace information into TRACE32 and analyze the code coverage of each subsequently until you end up with the code coverage result for the whole set of tests. The second approach is you analyze the code coverage for each test immediately, and you just add up the code coverage databases. Basically, you just merge them until you add up with the result you want to have. As I mentioned, TRACE32 is also possible to save or store the results. But a feature that goes beyond this is the possibility to document the code coverage results. You're basically able to export all the code coverage information that is visible in TRACE32 as XML file format to allow post-processing of this data. And additionally, we have XSLT style sheet, which can be used to display code coverage information in a browser, or because it is processed to an HTML data format. And what you see here, you have a window in TRACE32, and then you have here the representation in your browser. This feature was also implemented to give our customers the option to review the code coverage data without the need of an active instance of TRACE32 to separate those 2 things.